Okay, so this is the deliverable for task 1C, the video presentation, and this will be presented by myself, Ryan Dane Ryan, as well as by Chandni Ramnarayan. For the purpose of this presentation, I'll be going over the first part, where we talk about Active Directory, domain policy, and local policy, and Chandni will go over the second part, where she will talk about the VPNs, tunneling, radius, and the like. So research done for this was done by Darren Ali, myself, Ryan Dane Ryan, Chandni Ramnarayan, and Tanika Susano. So the first part of this presentation is about Active Directory. So Active Directory is Microsoft's trademark directory service. It is effectively a database of all objects that exist within a domain, inclusive of object attributes. This is where objects are effectively the users, computers, networking devices, printers that exist on a network, and attributes are simply the details of those devices. Excuse me. So this directory service is actually a proprietary service created by Microsoft for Windows Server environments. Excuse me. So the Active Directory is an integral part of the Windows architecture. It's a centralized and standardized system that automates network management of user data, security, and distributed resources, and lets interoperation with other directories. So Active Directory can be designed mainly for developing networking environments. So what is Active Directory actually used for? The purpose of an Active Directory or Active Directory server is effectively to have the centralization of user, computer, and resource access and usage management for the easier configuration deployment in larger networks. And there's a good reason for that. In the past, it was difficult for network administrators to manage a large number of pieces at a time. So, for example, if a manager came up to a network admin and told them, okay, all the machines on the network need to have Microsoft Excel by 9 a.m. tomorrow morning, and within the business there's 30 machines, you have to go to every single machine with a flash drive or perhaps a DVD and install that software. Now that's an incredibly time-consuming process, and to work around that, Microsoft came up with Active Directory. So the whole purpose of this of Active Directory is to allow a network admin the ability to make network configurations as it relates to users and computers from a centralized location, therefore eliminating the need to go to every PC on the network and manually configure each machine. Active Directory allows for these configurations to be pushed from the Active Directory server to all specified objects on a network. And in most networks where there are at least 50 machines, this is something that's required. So Active Directory also is also used by administrators to allow or deny access to specific resources on a network in regard to users. Now what this means is simply that Active Directory allows you to set up the security for certain users and their access rights as it relates to certain resources on the network itself. So a good example could be in the event where there's a shared folder for managers on a network where there's very sensitive company information. Obviously you don't want every user seeing that. So using Active Directory, it is somewhat possible to create or allow, well, not create, but to provide or deny access to certain resources on the network in regard to users and what they could access, therefore improving the internal security of the network. Active Directory also supports distributed network environments because it would be difficult for a large organization to store information and data on a network. And what this means is that in very large and almost incredibly complex networking environments, Active Directory still supports it because of its nature as somewhat of a phone book. So regardless of how large a networking environment can get, so long as the Active Directory is in place, it will provide the information about every object on the network that would usually be somewhat difficult for a large organization to store and manage manually. An Active Directory also allows for the creation of GPOs. Now, we'll talk about GPOs, but first, before we touch on that, we need to talk a little bit about OUs. OUs are simply organizational units. That's the abbreviation for it. And there are effectively a grouping of objects on a network that are usually logically grouped in some way. Most times it's according to perhaps location or functional area and so on. GPOs are really just objects on a network that can be applied to a certain group, and these objects possess certain rules or stipulations as well as configuration requirements. Well, not requirements, but certain configurations that can be applied to an OU. So a good example could be if a business has very stringent control over the security of the accounting department. Instead of having networking staff go to every machine on the accounting department and apply these very stringent rules, you can, as a networking administrator, you can simply create a group policy object where you can apply all the rules in a single object and apply them to a single OU, therefore allowing for a much more general control over the network. But in addition to a general control, Active Directory also allows for some level of granular control as well, as you can also configure certain machines or specific range of machines without the use of a GPU, but that's a little bit more advanced. So why is an Active Directory necessary? We touched on this previously, but Active Directory is necessary in most networking environments as it provides networking administrators the ability to manage and configure a number of machines in a remote and centralized manner, and it helps to remove the manual intervention. Active Directory helps remove the manual intervention associated with the management and configuration of client machines in regard to resources, security, and data. It effectively provides a more practical, economic, and cost-efficient method of maintaining a larger network. So basically, instead of having a bunch of people roam throughout the entire business every single day to attend one small networking need, you can have an Active Directory to do it from in a much more practical way, and that you just create the configurations from one machine and it's pushed to all machines that you require it to be pushed to. So this brings us to how Active Directory will support network infrastructure management. So Active Directory allows administrators the ability to have granular level of control over a network. As we said earlier, not only can you specify a single OU to be addressed, but you can also specify single machines as well. The nature of Active Directory allows for the creation of certain user objects, or more specifically user accounts on a network. So as part of the requirement for this part of the assignment, we were told to address this. So using Active Directory, right, you'll be able to actually create user accounts on network or user objects and specify all the information for these objects, as well as the protocols or the properties that would be unique to these objects as well as part of the user creation. So when you create a user account in Active Directory, you can simply go into their properties and configure whatever needs be. You can add them to certain groups. You can add them to certain OUs as well if you require that level of control. Active Directory also provides the ability to manage a number of machines all at once with a combination of OUs and GPOs. This was just discussed, but again, as a small refresher, if you have an OU, such as a functional area like accounting, and you require for everyone in accounting to have a certain security configuration or to have a certain piece of software, a GPO can be created and applied to that OU, so every single device in the OU, every object, every computer would receive those instructions from the GPO, and those instructions will be applied, therefore allowing for a very, very good management of a large number of machines all at once. So network resources can be easily managed, as Active Directory gives the ability to manage most, if not all, devices on a network, and not just devices, but also users as well to a certain degree. So let's bring this to local and domain policy. So domain security policy, what is it? Domain security policy is effectively a security policy that is specifically applied to a domain or a collection of objects that share networking resources. It's used for, or what is it used for? The domain security policy is simply used to set up security for a network. Security could be inclusive of password protocols, access levels, and other security concerns. So why is this necessary? This policy will give administrators full control of the security within a domain, allowing administrators to better manage the security of a domain and the data held on it through a much more convenient and somewhat centralized method through the use of a domain controller. So how does this support network infrastructure management and administration? This policy helps to support the network infrastructure management in that the system administrator will be capable of configuring and altering security requirements for a single domain. This configuration could refer to managing password policy, account lockup policy, configuring encryption, etc. for the entire domain. So all of this massive amount of information really boils down to the fact that domain security policy is just a general policy that's applied to every object within a single domain. Think of it as law, basically. Everyone within a country must abide by the law, regardless of who they are. You could think of a domain security policy in a similar way. It's basically a set of rules that everyone must adhere to in the real world. In terms of IT and domains, every computer on the network within that domain must adhere to a security policy provided for the domain. That's really how it works. That's honestly it. Just a general policy for every machine that sets a baseline for security. So that way, no one machine is without some stringent security policy that can end up being a security risk. And this brings us to local policy. Local policy is a hierarchical infrastructure used by network administrators to implement specific configurations of objects on a network, usually on a machine level. I apologize from now because my throat is really hurting doing this. This is like the 10th time I'm doing this, and it's a lot to talk about. So I'll try, but things are hurting, and I didn't think they would hurt. So what is local policy used for? This policy is used to define the user, security, and networking policies for objects on a network at the machine level. So a certain user would have security policy and access restrictions at a machine level, and there's a lot of stress going on about the machine level right now. Because while the domain policy would address things on a general global level, where it's everyone inside this domain, you listen to what the global policy says, and that global policy is basically saying, okay, everyone needs to have account lockout, everyone needs to have password policy, everyone needs to have this, everyone needs to have that. Local policy, on the other hand, is much more granular. It's just on the machine level. It's not about the network, it's not about the domain. So using the same example about laws, right? Now let's just say these laws are passed in a kingdom, for instance. And the king basically had a decree that everyone within his domain, his kingdom, must listen to what he says. But then you decide to go to somewhere else, perhaps an inn. And within that inn, there's an innkeeper. He says, okay, we have rules here too. And those rules will be a local policy. It's local to the inn, but it's also part of the domain. But that local policy only applies to the inn itself. Now, relating to the real world now, the domain policy would be a general baseline of security for all the objects on a network, but local policy applied to a specific object on a network, and only that object on a network, that specific object, would adhere to local policy. It's kind of how it works. It's basically like having two tiers of security, one global and one local. So why is a local policy even necessary? So a local policy is necessary for defining and configuring options that users can do on a network. This is inclusive of access rights to certain files or resources. Aside from access, this policy could be used to manage security and other user configurations based on the user, as these configurations are on the machine level. Again, stressing on this machine level so much, I'm getting tired of reading it. So how does it support network infrastructure management and administration? Local policy is much more specific than domain policy, as domain policy is on a global level, as I said earlier, but local policy is on a local level. Remember, just think about the inn and the kingdom. Kingdom says, okay, nobody commit murder, but inn's like, pay me if you stay here. Just two separate rules, but how they are applied are very different. One applies to a global level, everyone domain must listen, but on a local level, only that single object will listen. Well, the single object that the local policies apply to will listen. As a result of this, the use of a local policy would help network admins manage resources, security, and other security settings on a much more specific level, i.e. machine level. This would allow network admins to increase control over the network as restrictions, access, etc. could be configured on a machine level. So a real-world example, not using archaic things like kingdoms and payment and all those weird things. Real-world example. So say for instance a business has a domain, and within that domain they have several password policies and so on and so forth, and access restrictions. But a local machine could also have access restrictions as well. So that local machine, or the local policy for a machine, could basically say, okay, you cannot access X shared folder on this drive, but everyone else could. So that's basically what it boils down to. There's a global policy that everyone must listen to, and a local policy specific to a few machines that gives them either some more functionality or some less functionality in terms of security and what they could do. Right, and now I will pass you on to Chamli, who will go over remote access with you all. Thank you all for listening.
I will now be presenting on remote access. What is remote access? This is the ability to access a computer and to control it once connected from a distant location. This is best for telecommuters that may need access to the business's network or for server administrators who frequently need to update and make changes on server machines from another location. A remote access connection is only possible if a remote client software is installed on the local machine and the remote machine contains a remote server software. Remote access is also possible by using a dedicated line between a computer or a remote local area network and the central network. Even though a dedicated line is more expensive and less flexible, it offers fast data rates. Some common technologies of remote access include Integrated Services Digital Network (ISDN), wireless, cable modem, and digital subscriber line or DSL. Remote access can be set up using a local area network, wide area network, or even a virtual private network or VPN. I will now discuss virtual private networks. What is a VPN? This is also known as a remote access VPN and is a technology that provides a safe and encrypted connection to a network through using a less secure network such as the internet. It is a technology developed to allow remote users and branch offices the ability to securely access corporate applications and other resources. Users can access the secure resources on a network as if directly plugged into the network servers. This is possible due to different protocols used to secure and encrypt data, which include Secure Socket Layer or SSL, Transport Layer Security or TLS, Point-to-Point Tunneling Protocol PPTP, and IP Security or IPsec. How does VPN work? By establishing an encrypted tunnel across the internet, VPN technologies allow organizations to cost-effectively and securely extend the reach of their networks to anyone, anytime, and anywhere. There are two components required in remote access VPN. The first component is a network access server or NAS, or also referred to as a remote access server or RAS. A network access server allows the user to connect from the internet to use a VPN. This can either be by a dedicated server or by one of the multiple software applications running on a shared server. It requires the user to provide valid credentials in order to gain access to the VPN, where it then uses either its own authentication process or a separate authentication server on the network to authenticate the user's credentials. The second component is the client software. Users who want to use the VPN from their computers require software that can establish and maintain a connection to the VPN. Many modern operating systems already contains built-in software that can connect to remote access VPNs. The client software sets up the tunnel connection to a NAS, which is indicated by the user's internet address. VPN provides the following benefits and has become the most logical solution for remote access connectivity. It provides a secure communication with access rights tailored to individual users such as employees. It enhances productivity by extending corporate network and applications. It increases flexibility while it reduces communications costs. I will now discuss tunneling. What is tunneling? Tunneling is known as port forwarding and is a secure technique which enables a user to remotely access a network through a less secure public data network such as the Internet. Generally, this type of connection is point-to-point, although it is possible to have a multi-point tunnel connection. This encapsulates the layer 2, that is the data link layer, traffic from the remote user inside of the public network transmission units, and sends it through the public network to the other end of the tunnel where it is de-encapsulated and sent to its intended destination. This movement of data is secure as the encapsulation allows the private data packets to appear like if they are public data packets to a public network, which allows them to pass through unnoticed. Tunneling is beneficial to corporate settings because of its security features such as encryption, and also because it allows VPNs to be created over public data networks, which allows both sets of users to save money as they do not need to create a dedicated network. Some protocols which allow tunneling includes point-to-point tunneling protocol, PPTP, Layer 2 tunneling protocol, L2TP, and Secure Socket Tunneling Protocol, SSTP. Remote Authentication Dial-in User Service, or RADIUS. What is RADIUS? This is a type of protocol and software that allows a remote access server, in the case of Microsoft this is the Network Policy Server, which acts as a client to interconnect with a central server, that is the RADIUS server, to verify dial-in users and approve their requests to access a system or service. This allows a company to keep a central database of user profiles that all remote servers can share to assist in providing better security and allowing the company to apply policies to a single network point, which would distribute these rules throughout the network. This also helps the company to keep network statistics and track usage for billing easily. Radius is the standard network protocol used for remote access. A Radius proxy is a device that routes Radius requests, responses, and accounting messages between different Radius devices such as clients, servers, and/or other proxies. It uses information from the message to route it to the appropriate Radius device. This can be used as a forwarding point when authentication, authorization, and accounting has to happen at multiple Radius servers in various businesses. A Radius client is usually a network access server, NAS, and the communication between this client and the Radius server is based on the User Datagram Protocol, or UDP. The NAS passes the user's request, which consists of the user's username and encrypted password, and the NAS IP address and port to the Radius server, and takes action depending on the response returned, that is, the acceptance or rejection of the request. The password sent is encrypted to ensure that hackers cannot determine the user's password if they somehow intercept these messages. The Radius server receives the user's request, validates the user, and if the user is authorized, returns the configuration information which will allow the NAS to provide the service to the user. Radius servers support a variety of methods to validate a user. The server searches the database for the user's username. If the username is found and the password is correct, then an accept response is sent along with accounting messages, which can be a list of attribute value pairs that sets the constraints to be used for the session. If the username exists but the password is wrong, or if the username does not exist, a reject response is resent. The constraints that can be set indicates the amount of resources that can be used during the session. These resources include the length of time the session can last for, how much data packets can be sent or received, etc. Accounting messages are also sent at the end of the session with details regarding the resources actually used during the session. That is the end of our presentation, and these are the references that we have used.